This lesson is going to be on solving inequalities. So we have to solve, graph, and then state the max and the min, the highest possible value for x and the lowest possible value for x. When we're stating the max and the min, we're only going to state them as integers. I'm just looking for the maximum integer or the minimum integer. So I'm going to start by combining like terms on my left-hand side. So I have 7x plus 4 is less than or equal to 2x plus 14. Subtract 2x from each side. That gives me 5x plus 4 is less than or equal to 14. Subtract 4 from each side. I'm left with 5x is less than or equal to 10. And I divide both sides by 5, and I'm left with x is less than or equal to 2. So that was solving it. Now I'm going to graph it. To graph it, I'm going to have 2 in the middle. So I have 3 and 4, 1 and 0. Since it's less than or equal to, that means 2 is included. So it's going to be a closed circle. And I'm going to shade to the left. Now, for my maximum and my minimum, the minimum means how far left can I go. So since I'm going continuously to the left, my minimum value would be negative infinity. And the maximum is how far right I can go. So since 2 is included, it's a closed circle, my maximum would be 2. Solve, graph, and state the max and the min. So I have 6x is greater than or equal to. I'm going to combine these like terms. Negative 4 minus 4 is negative 8 plus 8x. Subtract 8x from each side. I'm left with negative 2x is greater than or equal to negative 8. I'm going to divide both sides by negative 2. And since I divided by a negative, I have to remember to flip my inequality sign. So now it's x is less than or equal to 4. So when I graph it, I have 4 in the middle, 5 and 6 on the right, 3 and 2 on the left. Since it's less than or equal to, that means 4 is included, so it's a closed circle. And since it's less than, I'm going to shade to the left. Now my minimum, since it's continuously going to the left, is negative infinity. And my maximum is how far right I can go, which is 4. Solve, graph, state the max and the min again. So I'm going to combine like terms. So I have negative 11n is less than or equal to 8 minus 9n. I'm going to add 9n to both sides. I'm left with negative 2n is less than or equal to 8. Divide both sides by negative 2. I'm left with n is greater than or equal to, because I have to flip my sign, negative 4. So now for my graph, I'm going to have negative 4 in the middle, negative 3 and negative 2, and then negative 5 and negative 6. Since it's greater than or equal to, negative 4 is included, so it's a closed circle. And since it's greater than or equal to, I'm going to shade to the right. Now the minimum is how far left I can go, which in this case is negative 4. And the maximum, since it goes to the right forever, my maximum would be positive infinity. Solve, graph, state the max and the min. So we have negative 5 plus 6 is greater than negative 7, parentheses 5n minus 6 minus 6n. So I'm going to start by simplifying the right side by distributing my negative 7. I'm left with negative 35n plus 42 minus 6n. Still have to simplify my right-hand side by combining like terms. Negative 35 minus 6 is negative 41n plus 42. I can add 41n to both sides. Negative 5n plus 41n is 36n plus 6 is greater than 42. Subtract 6 from both sides. 36n is greater than 36. Divide both sides by 36. I'm left with n is greater than 1. So now in my number line, I have 1 in the middle, 2, 3, 0, and negative 1. Now since it's just greater than, that means 1's not included, so it's an open circle. And since it's greater than, I'm going to be shading to the right. So now my minimum is how far left I can go. 1 is not included because it's an open circle. So my smallest integer value in this case would be 2. My maximum, since it goes to the right forever, would be positive infinity.